How's everyone doing today? Thumbs up, thumbs down? A lot of thumbs up, good, nice. There's no such thing as a thumbs down at NACIS. I'm saying that this is my first NACIS, so it's a good sign, you know. But yeah, my name's Nicholas. Thank you for having me today. Thank you for being here. My research advisors are Dr. Jace Bernhardt, Professors Ramiro Campos and Tiffany Cousins at Hofstra University. And I'm really excited to present to you all Ride, Sink, or Swim, which is a mapping project that analyzes how and where last year's flooding in Queens impacted bus performance and the residents who depend on those buses. So, let's hop on the NACIS bus and take you through the route of our presentation today. At our first stop, we're going to overview Queens and get to know our first research question. Where are the most flood-prone locations during major rainfall events in Queens, based on data from 2023? Second, we can stay on board for how we correlated precipitation records from New York State's Mesonet Weather Service with flooding reports from New York City's 311 reporting service. And then, next stop, next question, how impactful are street flooding hazards on the Queens bus system? So we're going to use data from New York City's public transit agency, the MTA, to look at the association between the locations of those floods and changes in bus performance. Finally, at the end of our journey, we'll chat about the larger and the local implications of our study and where we'll be going with the study in the future. And there is a fare for this ride, but I take payment in the form of questions at the end. That, or you could leave $3 by the door. I have to pay for grad school somehow, so. So just to do a little overview first, if you don't know, Queens is one of the 5 boroughs of New York City. It's the easternmost borough. It's the largest land area of all the boroughs, and it's surrounded by major bodies of water. So you have a lot of coastal neighborhoods, low-lying neighborhoods and elevation. Now, I started researching Queens about 2 years ago when the bus system was being redesigned by the MTA for better speeds and better reliability. And while I was doing that research, when my advisors, Dr. Bernhardt, asked me, has anyone brought up whether these floods we've had are actually impacting the buses? And to my surprise, I wasn't really finding anyone making that connection at the time. And we found this especially important in Queens because Queens is a part of New York City where if you're relying on public transit to move around, like a lot of New Yorkers, you're probably relying on buses for anything from work to errands to access to essential services. Low subway access is a given on any day, especially for residents of southern and northeastern Queens, where you have, most of the time, bus service filling the gap where train stations aren't actually available. And that's with roughly 110 routes that primarily serve Queens and its residents. But what does this all have to do with floods, right? Well, extreme flooding has become an increasingly damaging issue to New York City infrastructure and to New Yorkers' lives. And 2023 was especially bad. In Hamilton Beach, which is a coastal neighborhood just west of JFK Airport, we saw 7 storms where the recorded flood depth was over 5 inches. And September was a drastic month for rainfall. September 29th itself was actually a pivotal day when the remnants of Tropical Storm Ophelia dropped 9.8 inches of rainfall in 24 hours, which was quite a big amount. Now, that flooding debilitated infrastructure by blocking roads from use by emergency services, stranding residents at their homes, sometimes even away from their homes, and where subway access still actually was available, some of those stations got flooded, and that caused delays system-wide. So you see how these systems can come to a slow or to a halt. And these are not isolated effects just based on a street or a neighborhood. They affect a whole system of mobility and of city life. And with climate change intensifying these storms, we may only see the conditions get worse over time. But when it floods, the bus doesn't stop being essential. And that includes for over 2.3 million people who live in Queens, who take over 150 million bus trips per year. And that includes for going to pharmacies, hospitals, picking up prescriptions and groceries, childcare, elder care, and work and school, of course. And this happens across the 14 official community districts that Queens is divided into. And to get into what that means, these are those 14 districts here in red. And I want you to think of these districts kind of like the legislative districts a state would have, but they're, these boundaries where it divides communities into like advocacy groups. I don't believe they really have legislative power, but they do divide up the population into zones where the MTA has used these for community outreach efforts. We've found these appropriate for dividing our study into analysis zones, and this is how we're trying to figure out the local impact of these floods on the buses. So if we take a snapshot of street flooding from 2023, are we actually able to find an association with worse bus performance? And is that overall? Is that in specific community districts? Well, we started by looking at the amount of precipitation that fell across every month of 2023. And then we wanted to choose a study time frame from there. So we assumed that meteorological fall, right, so September, October, November, would be our experimental season. You saw September alone is the rainiest month of the year. You're getting over 17 inches of rain, and that was a real outlier season. So that's our experimental period. But we also needed to identify a control season to compare that to. One where rain falls in more typical amounts, doesn't have huge abnormalities to skew our data. And we realized that winter weather and abnormal wildfire smoke that New York saw, you might have seen reports about the red skies over New York that summer, all of that could have affected bus performance, like speeds, traffic, ridership, and we didn't want that impacting our data. Meanwhile, spring 2023 was not particularly an outlier in the year, and while April's total rainfall is higher than the median, that was rainfall over many non-consecutive days, and it was less than what we saw in the fall. So we found it appropriate to compare fall versus spring. So we have rainfall data for 2 seasons now, so it's a great start. Now, how can we actually tell where streets flooded and where they didn't? Well, the best street-level record we have of flooding in New York City is the NYC 311 database, which I call the biggest complaint box in the Big Apple. And it really is. It's used to report any issue you want to see fixed by the city in your neighborhood, as long as a department of the city can come in and take action on that. And the strengths of this data set are that this service is accessible across Queens, across New York City. Residents can report problems by phone, by text, website, or their app, and that includes street and highway flooding reports. And when we look at that data set of reports, which is all publicly accessible from the city, you get street-level coordinates of those complaints. So it's really easy to just go plot it on a map and start analyzing it from there. Plus, it's been used in multiple studies, and that includes a study that's multiple that have looked at flooding using 311 reports and correlating it with actual occurrences of flooding and finding an association there. Now, the biggest pitfall I did want to mention is some studies highlight a skew in these reports towards areas that have higher income and higher property values. And that's a really important association to consider there because we want to get an accurate picture of flooding, as accurate as we can. So to avoid being biased by that skew, our general mindset is if a flood was reported, we can assume it occurred. But absence of a report somewhere doesn't necessarily mean there wasn't a flooded street there, right? So I want you to take our results and consider how they might affect have an effect across the entire borough, even in those spots without reports. And by summarizing this data by community district, we also hope to avoid that skew towards smaller, affluent neighborhoods. And to avoid duplicate reports, we're also just looking at unique 311 locations of flooding, not all reports, considering there are duplicates. So, when we summarized those unique 311 locations by month, what we found is that each month where you see rainfall increase over the previous month, you do see the number of 311 locations increase too. And that's especially evident in September. That was, our outlier for rainfall. You also see it's an outlier in flood locations with over 250 being reported. September alone had 50% more flooding locations than August, which was the next most reportedly flooded month. So it was a very big difference there we noticed right off the bat. Now, where did we see that flooding distributed? Well, when we take a look at the map, between spring and fall, as rainfall increased, we saw all districts except one, Community District 5, have increased 311 street flooding locations. So, when you take this into account, did we see a difference in bus performance associated with the greater number of flooding reports? Well, first, before we get to that, how do we actually define bus performance in this study? Well, the MTA measures what they call monthly on-time performance data for each route in their system, and that's the percentage of trips that are completed within 5 minutes of when they're scheduled to arrive. So just think of it as the percent of trips that a passenger gets on and then gets off the bus on time according to the schedule. So our steps for mapping this involved a script I wrote in R that calculates the median on-time performance per month for every unique community district. And then that script for each community district uses the unique routes within that district and their on-time performance data, puts it into a nice little median package. Then also in R, I calculated the median on-time performance per month for all routes across Queens. So we got that overall data set for the year, which you can see here. And what we found is that in peak hours, which is what you're seeing, median performance ranged from as high to as 74.7% on time to as low as 61.8% on time. And big shocker, you see the lowest value happening in September right here. In fact, the bottom 3 months in performance are September, October, and November, all in the fall. None of those hit above 63% on time. In the spring, we saw March and April roughly hit median performance, so it's pretty good. While April was actually the 3rd best month of the year for buses with a 73.5% on-time rating. Now, if you remember when I said September had 50% more flooding locations than the next most flooded month of August, well, when you look at August to September, you also see a 14% drop in bus performance between those months. So the impact is really profound, and if that drop is caused by floods, it would be incredibly pressing. And when we put that on the map, you see in peak hours, which I should explain, these are weekdays. Basically, if you consider it rush hour, that's 6 a.m. to 10 a.m. and 4 p.m. to 8 p.m. in New York City. Well, the darker reds indicate worse bus performance per community district. And in the fall, we saw that bus performance decrease in 13 districts, and increase only in one, Community District 14, which is particularly coastal, and we're going to be looking into why that's an outlier there. And this is just what the MTA calls peak hours. So what about off-peak? What about everything outside of that time frame and weekends? Well, off-peak, you see less intense performance deficits, but it's still a drop across the board, and this time in all 14 districts. Now, there's more nuance to this than saying, oh, well, the bus is bad everywhere when it rains, when it floods. No, it's a bit more complex than that. Queens is massive. There's differences in elevation and traffic and drainage systems between community districts. It isn't necessarily fair to generalize, right? And that's why the other half of this project is to identify the communities that are most affected by this issue. So if you're wondering which communities those might be, which districts saw increased flooding and worse bus performance, that's where we were too. But it happens to be easier to show you a map of districts that didn't see that impact. And these are those districts. It's only 4 of them where we found outliers to the trend, where either they had decreases in flood locations overall, but still worse bus performance, or they saw an increase in flooding that just didn't seem to impact bus performance at all. So in the future, we're going to be exploring these areas more in depth to understand how their change differed from the overall trend. But for those 10 districts where flooding and bus delays were associated, well, the next step is to understand how that trend affects the daily life of the residents. So what can we take away here? Well, in 2023, we saw more streets reportedly flooded in the fall than in the spring. On top of that, we saw multiple examples of declining bus performance across nearly all of Queens in the fall. Now, the other half of this picture is focusing on those local trends, seeing which neighborhoods have their transportation most impacted by flooding. As the problem continues, the city's going to need concrete data to allocate funds and to start projects to create a solution. And we want to contribute to that data. So our next step is studying these maps on the smaller scale, block by block, to see what we can find. On top of that, uncovering local differences in flooding and buses will hopefully help us understand the impact of other variables like traffic congestion, elevation, and drainage too. It might be that fixing those issues, those infrastructural issues, especially in the most vulnerable communities, is going to be where the solution to this issue lies. And we'll find out maybe through science. But I really want to thank you for your attention today. I hope you'll look forward to the final study. It's part of my thesis this December, so I really got to work hard to get that finished. But I also love to connect, so feel free to check out my website too, or pay your fare by asking any questions now. So thank you so much. We have time for questions. Great. Yeah.
Have you looked into the density of the bus network in each of the community districts and how that might contribute to the on-time performance? I know like some of the more far-flung districts closer to Nassau County might not have as much density in terms of bus service. Also, like they're being served by buses from other neighboring counties.
That's a really good question. Thank you. Yeah, so the question is essentially, have we looked into if the density in different density of bus service in different community districts affects their bus performance? Well, pulling up the map here, the person who asked the question made a really great point, which is that if you're looking at Eastern Queens, it's bordering Nassau County. You do have less density, population density overall, and we do see lower density in the number of bus lines in those areas. And we also paid attention to areas that are particular like transit hubs like Jamaica and Flushing, and whether or not density of those bus lines affects the performance. And overall, I wish we had it on the presentation, but what we've been finding so far is those transportation hubs do see a negative impact to their bus performance. And that's because, first, you have a lot of buses running. And second, they're often areas that are just generally congested by traffic, too. Congestion absolutely plays a part in this on top of the flooding, which is making those bus performance numbers, possibly making those numbers decline. And I think what's just important to note with the density question of bus lines is that congestion in one place on the bus line or flooding or any variable can affect performance on another place in that bus line. So you might have lines that start in Jamaica where there's dozens of buses that pick people up. And then further out on the route, you see the impacts in Jamaica affect that performance. So even in the lower density areas, you may still see impacts to performance. We do really want to keep looking into that, though. So thank you for the question. All right, one more question. Let's see. Yeah, over here.
Have you compared bus performance year over year to see if it's related to the flooding or just a seasonal change? For instance, in September, students are going back to school. The way people move in the city changes in that season. How convinced are you that it's related to the flooding?
Yeah, excellent question. So how convinced are we that bus performance drops are related to flooding and maybe not just changes in traffic? Well, generally, I have considered that a lot, and including your question year over year. So I'll just say our study right now, the scope is solely 2023. It would be really fascinating to look at other years, especially 2021. There was a lot of the remnants of Hurricane Ida. That was my first night of school at Hofstra, and I do remember the flooding, and I remember how that impacted my classes because professors couldn't even get to us, by car or anything. So when we look at other years, well, I would love to do that. But when we talk about how, that association with traffic. I feel, being a good scientist, I'm not saying correlation equals causation, but considering the fact that traffic in New York and in Queens is a given, and you look at the area towards the western part of these maps, you have traffic going between Manhattan and Queens, for example, which having rode a bus through that route causes congestion, definitely year-round. But I think that traffic is a year-round pattern. You're right, students go back to school in the fall, for example, but generally, if they're in the school in the spring as well, which is part of why we compare these two seasons, that's pretty consistent traffic between the seasons. So if you consider consistent traffic, we also saw the addition of flooding lowering bus performance numbers. I would consider, flooding to be a variable that, I'd be confident that has an impact on the data, on top of congestion, on top of drainage, elevation variables. So I think what we're looking at is a multi-variable problem here, where flooding, to me, I really believe has an impact in it. Yeah. Thank you for your question.